Okay guys, let's solve this problem number 42, which says to solve this rational equation. So we're trying to figure out, what does k equal? That's what it means to solve. It means trying to figure out what k equals, what the variable is equal to. So how are we going to do that? Well, we don't like fractions very much. So the very first thing we're going to try to do is get rid of the fractions. How do we get rid of the fractions? We need to come up with what's called a least common denominator. Least common denominator. If we multiply both sides of our equation, every single rational expression, by the least common denominator, we will be able to get rid of all our denominators. So how do you figure out the least common denominator? Well, the least common denominator is really just if you take all of the factors of every denominator and get at least one of each in there, that'll get rid of all your denominators. So let's try to figure out what are the factors here. So what are the factors of this denominator? Okay, so I only have one factor here at k minus 1. That's just one factor, k minus 1. I can't factor it anymore because the k is linear. It's got an exponent of 1. So that's already as factors as you can get. In this denominator, what are the factors? Only one factor here again, just a k. And its exponent is 1, which means that its factors as it can get to. It can't be factored anymore. What about this? What about this denominator right there? Can k squared minus 3k be factored? I think it can, and the reason that I think it can is because it's quadratic. There's a squared on this k, an exponent of 2. So how am I going to factor this denominator to be able to find the factors so I can get my least common denominator? I'm going to try GCF first, because that's the first thing you always try when you're trying to factor. Can I take out a common factor? And in this case, I can take out a k. If I divide a k out of both terms, I get k minus 3 left. Okay, so I'm going to just take that denominator and I'm going to rewrite it as k times k minus 3. K times k minus 3, which is the same polynomial, just factored instead of in the standard form. Okay, so now I can pretty easily see what all my factors are. In the first denominator, I've got a k, and I've got a k minus 3. In my second denominator, I've got a k, but I've already got k in my least common denominator, so I don't need to add another one. I just need each factor once. And in my last rational expression, I've got a k minus 3 in my denominator, but I've already got a k minus 3 in my least common denominator, so I don't have to write that again. Again, you only have to have each factor one time. Okay, and it's pretty easy to see now that if I multiply everything, by the k times k minus 3, that has enough, that expression has enough in it to cancel every single one of my denominators. So now what am I going to do? I'm going to take this expression and I'm just going to distribute it into all of my rational expressions. So here's what that's going to look like. I'm going to have k times k minus 3 times, I'll have times this rational expression right here, which is k plus 3 over, and then the denominator, this we already factored it, and we factored it to k times k minus 3. K times k minus 3 is going to distribute into this rational expression, and I'm going to get 1 times k times k minus 3 in the numerator. And in the denominator, I'm just going to have just what's in the denominator here, k. Just 1k. And then in my third rational expression, I'm going to have the least common denominator distributed into this third rational expression as well, which is going to give me minus 1 times k times k minus 3. I wrote my k weird. K minus 3 all over k minus 3. So check this out. I wrote the k times k minus 3 in the numerator of that fraction and in the numerator of that fraction, but I wrote it right next to the numerator of that fraction. The question is, does it matter? And no, it doesn't matter. You can write it either way for any of these rational expressions, because when you write something alongside a fraction, basically touching it right there, that means multiply. And when you multiply times a fraction, you have to multiply into the denominator. So this expression right here would be the same as if I had put k times k minus 3 inside the denominator, just like I did with these. And these expressions are just the same as if I put k times k minus 3 next to these equations, like I did with this one. It'd be the same thing. So you can write it in the denominator, you can write it next to the denominator. It doesn't matter. Either way, it cancels, which is what the next step is. That's the whole point of the least common denominator, is to cancel factors that are in the denominator, and then they're also either in the numerator or alongside the fraction. It can cancel either way. So this k minus 3 cancels as well. And this k cancels with that k. And that k minus 3 cancels with that k minus 3. So what am I left with after all the canceling? Well, I'm not left with any denominators, that's for sure. That's exactly what I was trying to do all along, was get rid of all my denominators. So I've got k plus 3. That's the only thing left over in my first rational expression. In my second rational expression, I have 1 times k minus 3. And 1 times anything is just itself, so I'm going to write that as just k minus 3. And then I've got minus 1 times k, which is just minus k. It's just minus k. All right. What can I do to simplify this expression that I have now? Well, it looks like I can do some stuff with like terms here. So k minus k, that's equal to 0. Okay, they cancel each other out. So all I've got left on this side is really negative 3 when I combine those like terms. And then on this side, I've got k plus 3 still. Now, it's pretty easy to tell what k should equal now, because I've got k plus 3 is negative 3, and I'm trying to get k all by itself here. So all I really need to do is subtract 3 from both sides. And what's the answer to that? I've got k is equal to negative 6. The only thing I need to do now is make sure negative 6 really does work for my original expression. And the only reason it wouldn't is if it made one of the denominators 0. Because when you make a denominator 0, it's like you're dividing by 0, which doesn't work in math. It doesn't work to divide by 0. So I got to make sure this negative 6 doesn't make any of my denominators 0. The first denominator would be negative 6 times negative 9. They don't make 0. The second denominator would be negative 6. The third denominator would be negative 9. None of these denominators would be 0 if I put a k in there. A negative 6 in there. So this is not an extraneous solution. It's my actual solution. It's my real solution. So I'll box it up, and that problem is done.